Hi students, welcome to HSC Earth and Environmental Science and Module 6 on hazards. This is our last little section, the beginning of our final inquiry question, where we start to look at ways of predicting and minimising the damage that can be caused by some of these hazards we've identified in this module. So in this first one, we're going to look at how some of the technologies that we have developed have been applied to volcanic eruptions. There's several of these subsections that we're going to look at. We're also going to look at earthquakes and east coast lows. What we want to do is to use some secondary sources to evaluate the effectiveness of technologies in predicting natural disasters, which in this particular video is going to focus on volcanoes. So we need to discuss 3D imaging, seismic data, early warning systems, ground movement data, and analysis of historic data. So what we're about now is trying to understand how some of the technology that we've used can be applied to our understanding of when volcanoes are likely to erupt and potentially the kinds of eruptions that we're going to get, particularly that difference between effusive and explosive. So what they require is scientists to use a variety of techniques. So really that's about trying to hear and see what's going on inside a volcano. The USGS Volcano Hazards Program monitors volcanoes regularly, and they are equipped to send out early warning systems, which we'll look at later, that come with high levels of data and also confidence, and therefore often are responded to in an appropriate way. Unfortunately, there's been a little bit of a history of scientists predicting some volcanic eruptions, getting some idea of what's going to happen with a volcano, and then for whatever reason that advice wasn't acted upon, and lives and property were lost. So what we want to try and do is we want to look for ways in which we can tell whether a dormant volcano is actually going to become active, or whether a volcano that is a little bit active, that's been bubbling away for a little while, is actually going to go through an explosive event. So we want to try and find out some of the ways that we can identify from a volcano, and certainly from some of the things that are happening within the volcano that we may not necessarily be able to see, how we can predict when that volcano is going to erupt. And there's a nice little checklist of things that we're going to be looking at. Earthquakes and ground movement, as well as volcanic gas. These are things that we have a couple of different ways of trying to measure. We can use the rock chemistry and the water chemistry that are part of the way that these might change, that indicates either some historic data for us to use in our predictions, or some immediate data that's going to suggest some future eruption event. And also we're going to look at 3D strategies or technologies that are helping us to build a big picture of what's going on with volcanic eruptions. So we want to try and do this on a continuous or near real-time basis, so that if we do gather information that suggests a volcano is about to erupt, we can give the people who are going to be most likely to be affected by that volcano enough time and notice to be able to respond. So when you're going through this section, one of the things, and I think this is probably true for all three of these, so volcanoes, earthquakes, and east coast lows, what you want to do is look at some of the technologies that are being used, a description that helps you to analyze what's happening there, and also some evaluation, some degree of efficacy. So efficacy is another word for efficiency. So this is where you're making your value judgments. And if you're going to make value judgments, then you need to make sure that you've got as much information as possible. Now, tabulating information can be a really good way of helping you to focus exactly on the information that you need, because obviously if you set up a table, then you can give yourself a little tick in each part of the table when you know that all the information is present. And it means you haven't left anything out. Of course, the problem with tables is that they can be oversimplified, and this being a video that I don't want to go on for hours means that I have oversimplified this a little bit, and hopefully you'll pull some of these details out. So one of the things that we can do in terms of volcano monitoring is to also look at earthquake activity. So we have a number of seismic stations with their seismometers that are constantly monitoring seismic activity, earthquake waves, and sometimes we find that volcanoes that have been dormant for some time, if they're going to start to fill with magma and they're going to start to prepare for an eruption phase, often there will be some little spikes in the, or changes at least in the seismic activity. So small tremors, often ones that are too small for us to detect them physically, but which can still be detected by the equipment that we use, can indicate the shift from a dormant volcano to an active volcano. Of course, as the magma is building up, there may be some pressure that's building up. This shift might change from small tremors to slightly larger tremors, so more significant earthquake activity, and this can be a precursor to an imminent eruption. So we can look at seismic data and give us a little bit of indication about what might be happening around a volcano. Another area that we can monitor is ground movement. And this can be as simple as kind of seeing a bulge occur on a mountainside where you're thinking, and this is kind of the sort of thing that was happening a little bit around Mount St. Helens before it erupted. So we had that kind of bulge starting. You might also find when we talk about volcanic gases that there may be some steam, some ash, some other gases that are starting to escape from the sides of these kind of swellings. And also we use devices like strain meters and tilt meters. And these two devices, often we find them sitting in boreholes or down underneath the ground surface. And these are extremely accurate, and they are able to measure very precise changes, very, very small changes that might occur that we might not notice from the surface. And yet they can give us information about changes in magma activity that's happening under the ground surface, which may be indicating that a magma chamber is filling. They may also give us indication that something is about to change in terms of something that's going from an infilling chamber to an actual explosion. And this can happen simply because of a change in the pressure. Maybe there are gases starting to escape. Maybe there's water that's now being heated into steam, and that's creating additional pressure. So there's a couple of different things that those kind of minor movements of the ground, not necessarily associated with earthquake activity, but they can be. But anything that's kind of just shifting around a little bit, that's telling us something is different in this environment. I mentioned too that there can be a number of gases that can be emitted through either small vents that might be appearing around the sides of a swelling that might be occurring, which, as I said, it was the case for Mount St. Helens. And this appearance of ash or steam, increase in sulfur, potentially carbon dioxide emissions, all of which can be used through the process of mass spectrometry. So mass spectrometers are devices that are able to break down individual compounds into their elements, and will sometimes even give us a little bit of an idea of the different isotopes that are present within different elements and compounds. And so they can give us almost, I guess, what you might regard as chemical signatures or fingerprints of particular chemicals that are present in an area. So we might be able to see from just a process which allows us to monitor the gas in a certain area, whether or not the composition of the gas is changing, and potentially whether that changes can be linked to an increase in volcanic activity. A couple of other things that you can quickly talk about include early warning systems. Early warning systems is one of the things that I mentioned earlier on, which is that if we've got a lot of information, we're getting our information around deformation or changes in the ground surfaces from seismic data, if we see changes in the seismic activity, also from any gas emissions, any materials that are coming and changing the composition of the air, that each of these can be a piece of confirmatory evidence that might be suggesting that we need to perhaps issue an early warning. Obviously, this is ideal if we can try and move people out of an area if we think that a volcanic eruption is going to occur. But often the the type of data, the extensive detail that's in the data can influence whether or not those early warning systems are taken seriously. And of course, sure you've seen movies where the scientists are the ones saying the world is about to end, and everyone's going, well, you know, what do scientists know? So what's nice to see is that there's been a number of different countries that have set up specific agencies that are about monitoring these sorts of potential activities, potential disasters. And so when that data is released, when those early warnings have to be issued, if they are, then often people are respectful and quick to respond in those situations. Another area is historical data, and one of the things that feeds into historical data is rock chemistry. So we can actually have a look at the igneous deposits. We can get a bit of an idea of what sort of volcanic eruptions have happened in the past. Have they been effusive? What types of igneous rocks have we got? Have they been explosive? Have we got lava flows? Have we had evidence of lahars? What's been going on in the past, and can we construct timelines basically of frequency and intensity of eruptions in the past, and as a result perhaps recognize patterns in the data and maybe use those to predict some sort of future eruption, either the likelihood of one happening in the next little period of time, the nature of that eruption. Is it going to be effusive? Is it going to be mild, slow, steady, or is it going to be explosive? Is it going to potentially damage large areas around the volcano, maybe even blow the sides of the volcano? Historic data is going to be set into that context of plate boundaries. So volcanic eruptions are also a function of where those volcanoes are located in the world, and whether or not they're sitting over hotspots or they're sitting over areas of plate boundary like a subduction zone, and how that's going to influence each of those different types of potential eruptions. And one other thing we might quickly talk about are 3D analysis. So information that's coming from remote satellites, from radar technology, or from any of the other types of data that we've collected already. So we can talk about seismic data, we can talk about ground monitoring and gas emissions. All of this can be put together to produce three-dimensional images, maps of the ground that can occur both as a topographic map, getting a sense of how the ground is formed, what's going on, with or without the vegetation on the top. Different parts of the electromagnetic spectrum can be used by different processes, such as INSAR or LIDAR, and they will use different wavelengths of light within the electromagnetic spectrum to bounce those radio waves off the surface back into satellites, and to put that information together using computer technology to build these three-dimensional maps. And so therefore, if we've got these maps, we can very quickly see if anything is changing as a result of these, any activity that might be occurring underneath, and again, provide nice early warning systems for the sorts of things that might be about to happen. So one little activity that we can look at in class, and the GeoETC website is absolutely fantastic. I can't recommend it enough. There's a lot of really great resources on there for you to have a look at, help your understanding of earth and environmental science. And they have a great little simulation called Thunder Island, where you get a chance to have a look at some of the simulated data that we've been talking about in this video, put it all together to see what sort of information you can conclude, what you would conclude from the data that's being presented. So that's a little interesting activity to have a look at, which we will look at in class. Thanks for watching.